In today's lesson, we are going to be looking at parallel and perpendicular lines, as well as horizontal and vertical lines. So we're going to start with parallel and perpendicular. Right? So you might have heard these terms before, hopefully you have. And parallel lines, by definition, are lines that will never touch. And what's unique about parallel lines is that their slopes are the same. So in order for them to have or to never touch, their slopes need to be the same, right? Because that means they're traveling or they're increasing at the same amount so that one never jumps ahead or one never lags behind, so that they always kind of continue in sync. Right? We might say, well, what if they're just on top of each other? Well, then if they were on top of each other, they would be the exact same line. So parallel lines, slopes are the same. So just some comics on parallel lines, right? We come from a parallel universe. What are parallel lines? They're vegetarians, huh? They never meet. Parallel lines, two lines that never meet. Me and my healthy sleeping habits. Yeah. So just some more humorous examples of parallel lines. Perpendicular lines. Perpendicular lines mean that they meet at 90 degrees or a right angle. So if they are perpendicular, they meet at 90 degrees or a right angle. And these slopes, they're not the same, but they are what we call negative reciprocals. And negative reciprocals means that they are flipped and the opposite sign. So for example, we see here, one slope is 2, the perpendicular slope is negative 1 over 2. Another example, say this had a slope of, let's say 5 over 2. This would have to have a slope of the negative reciprocal, meaning that we flip it and it's the opposite sign. So if we were to flip it, that's 2 over 5. And if because this is positive, this would have to be negative. So those would be two examples of negative reciprocals. Again, some more comics. Don't be frightened, I'm you, but I come from a perpendicular universe because they're at 90 degrees. Ha 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 ha. We've opened a portal to a perpendicular dimension. We've opened a portal to a perpendicular dimension, right? Because a lot of times you hear parallel dimensions, right? The same kind of thing, just moving in a different kind of different starting point, right? But moving in the same way. So you see the TV shows where it's the same thing, except maybe it's a different theme, right? Maybe it's everything's in black and white, or one's a cowboy universe or something like that. But it's the same thing. Everyone's just dressed as cowboys, and yeah. So this is obviously a joke on that. Parallel lines have a lot in common, but they never meet ever. You might think that's sad, but every other pair of lines meets once and then drifts apart forever, which is pretty sad too. So kind of like our perpendicular lines, right? They will meet once and that's it. So let's take a look at some examples. So first, we want to determine the slope of a line parallel to the given line. So all this is really requiring us to do is just identify the slope and then use our knowledge of what a parallel line is. So if I were to look at this equation, right, remember our general equation is y equals mx plus b. So in this case, what is my m value? Well, it's -5. So that means that my multiplier or my slope is -5. So if in order for it to be parallel, the slope of a new line must also be -5 because it needs to be the same thing. In the second one, again, looking for that slope, the value that's attached to the x, the multiplier, so m equals 1 over 3. In order for it to be parallel, it must also, the parallel line must also be 1 over 3. And it needs to be the exact same slope. Next example, determine the slope of a line perpendicular to the given line. I don't know why some of it got cut off here. So again, y equals mx plus b. Let's look at the multiplier. In this case, it is 4. So if we want a perpendicular slope, kind of use the little perpendicular 90-degree angle there. If we want it perpendicular, our slope has to be the negative reciprocal. So we need to flip this. Well, I can't flip it if it's not a fraction. So how do we make a whole number a fraction? Remember, we did this when we were determining, or when we had to graph it. We needed the rise over run. So we put a whole number over 1. So 4 over 1 is what this slope actually is. In order for it to be perpendicular, we need to do the negative reciprocal. So we need to flip it, make it 1 over 4. So we flipped it, but we also need to change the sign. So negative 1 over 4 is our perpendicular slope. For b, we see our slope is negative 1 over 2. So it's nice. We don't have to change anything. We see the two numbers. We see it's as a fraction, which is easier for us because now when I flip it, or the negative reciprocal for our perpendicular slope, when I flip it, it becomes 2 over 1. And instead of being negative, it becomes positive. I could then just rewrite this as 2, because 2 over 1 is the same thing as 2. So that would be the slope of a perpendicular line. Next example, state whether the lines with the slopes are parallel or perpendicular, or should say neither. Again, I don't know why it's cut off. So if I look at the first one, these are just the slopes. I'm just looking at the slopes and determining whether it be parallel, perpendicular, or neither. Well, if I look at the first two, 1/2 and 2, they are flipped. However, they're both positive. So because they're both positive, even if they're flipped, they're not perpendicular. They're not parallel because they're not the same. So this would be neither. For b, the first slope is 3. The second slope is negative 1 over 3. So we have a positive and a negative, which is good. We want to have one of each. And we see that they are reciprocals. They're flipped, right? 3 can be flipped to 1 over 3. So this means that these two slopes will be perpendicular. And lastly, 2/3 is our first slope. 4/6 is our second slope. First glance, you might say, well, it's neither. They're not the same. However, 4 over 6 is the same thing as 2/3. If I reduce it, so these two slopes are actually the same. So they are parallel. Next example, write an equation of a line perpendicular to the line 8x minus 4y plus 12 equals 0. Now you might say, well, that's not an equation of a line. And you'd be right in the sense that we normally see it as y equals mx plus b, which we just mentioned here. This equation is written in what we call standard form. 8x minus 4y plus 12 equals 0 is an equation of a line in standard form. And what we need to do is we need to arrange it into y equals mx plus b first. So 8x minus 4y plus 12 equals 0. And I want to get it to look like y equals mx plus b. So I need the y on one side and then everything else on the other side. So let's do that first. So I'm going to move the 12 over. I get 8x minus 4y equals negative 12. I'm going to move the 8x over. So I get negative 4y equals negative 8x minus 12. And you might say, well, I have the y on one side, I have the x on the other side, and I have everything else on the other side. Which would be true, except we need to get the y by itself. So I need to divide by negative 4. And I need to divide everything on this side by negative 4 as well. So y is left on its own. Negative 8 divided by negative 4 is 2x. And negative 12 divided by negative 4 is positive 3. So now this is the equation of my line. It's not the perpendicular line, it's of my initial line. And the reason we need to write it in standard form is because now it's really easy to figure out what my slope is. So by looking at this, I can see that the m value, or the slope, is 2. So if I want something that is perpendicular, I'll do this in purple. If I want something that's perpendicular, I need to have a perpendicular slope. So it needs to be perpendicular to 2. So in this case, I need the negative reciprocal, which is 1 over 2, and negative to make it the opposite sign. So I need to write an equation with this as my slope. So y equals negative 1 over 2x. And the b value can be whatever you would like. It could be nothing. You could put plus 5. You could put minus 100. The b value doesn't matter. The only thing that we're really concerned about the only characteristic of our line that makes it perpendicular is the slope. So this is the only thing that we're worried about. So I'll just put, say, plus 2 just on the end to have something there. But the only thing that we're really concerned about is the slope, because that is the indicator of whether it is perpendicular or not. Last example, or for at least perpendicular lines and parallel lines, a triangle has vertices A, negative 2, 5, B, 6, 8, and C, 1, negative 3. Is this triangle a right-angled triangle? So going through this, is it a right-angled triangle? Right-angled means 90-degree angle. 90 degrees would mean perpendicular. So let's start with the information that we're given. We're given 3 points. So even if we have no idea what to do, let's graph those 3 points. Right, remember that for a point, it's x and then y. So negative 2 and then 5 is 1 point. 6 and 8 is another point. And 1, negative 3 is another point. So I want to see, I'm going to use a ruler to connect these. I want to see if these two, if these points form a triangle that is 90 degrees. Now I have accurately kind of drawn my points A, B, C. Now in order for it to be a 90-degree angle, right, or in order for it to be a right angle triangle, there needs to be a 90 degrees. So looking at this graph, or at these points and these lines in this triangle, I could clearly tell, even because it is nicely plotted, that angle C and angle B are not going to be 90 degrees. Right? If there is anything that will be 90 degrees in this triangle, it would have to be angle A. Right? That would have to be 90 degrees. So our goal is to check, is that 90 degrees? Now the way we do that is we check the slope of the two lines that form that angle, and if they're perpendicular, they would be, or that would be a 90-degree angle. So I'm going to find the multiplier or the slope of the line going from A to B and from A to C. Right, so if I want to, I'm going to create a quick table. X, Y, so A is negative 2, 5, B is 6, 8. Check my multiplier, or my change in Y is plus 3. My change in x is plus 8. So my multiplier is 3 over 8. All right, let's check AC. Create a table. X, Y, A is -2, 5. C is 1, -3. So if I look from 5 to -3, that's -8. From -2 to 1 is +3. So my multiplier, change in Y over change in X, is -8 over 3. They are perpendicular. So AB is perpendicular to AC. So this means, so therefore, it is a 90-degree, or not 90, a right-angled triangle. So therefore, it is a right-angled triangle because we've determined the slope for these two lines, and we found that they are perpendicular to each other. Because we found that AB is perpendicular to AC. Now, if you wanted to, right, maybe you didn't plot these points out, you could check CB. Right? Maybe we mislabeled it, or maybe we didn't quite plot it correctly. Maybe our graph or our scale was off. Right? So CB, doesn't matter which one we put first. We'll do C. So 1, -3, and then 6, 8. So if we were to look at this, this is a +11. This is minus or +5. So the multiplier here would be 11 over 5. So this does not match the other two, which is fine. It doesn't need to be, right? All you need to have are two lines that are perpendicular. Right? You don't need to have the third one be anything. It doesn't need to be parallel. It doesn't need to be perpendicular to the other ones. It makes sense that it's neither. Right? Because if it was parallel to the other lines, it wouldn't form a triangle. If it was perpendicular to another one of the lines, it wouldn't be perpendicular, especially with these two already forming a right angle. So you could check the third one, but the main thing you're looking for is that we have a pair that are perpendicular to each other. Horizontal and vertical lines. So looking at these two, right? So hopefully we're okay with the concept of horizontal and vertical. We're going to look at how it looks on a graph. Right? So given this graph, we want to determine the equation of the line. Right? So we talked about we could find our y-intercept, right? Go down. There's our b value. We could do rise over run from one point to the next. So we're just, in this case, our rise 0, our run is 2. So the m equals 0 over 2. We could also do this as a table. Plot some points. So we have 0, 2, we have 1, 2, we have 2, 2, 3, 2, 4 would be 2 as well, 5 would be 2 as well. So if we go through and plot this, or do our change in y, I'm just showing you the different ways. Right? From 2 to 2, that's a change of 0, 0, 0. This is a change of 1, of 1, of 1. So similar to what we just found, our multiplier is 0 over 1 or 0, which would be the same thing as 0 over 2 would also be 0. So my multiplier is 0, and I see my b value is 2. So my equation, therefore, y equals 0x plus 2. Let me color code it. 0x plus 2. But there is one thing I could do. Because it's 0x, what's anything times 0? Anything times 0 is 0. So what we could do is then just get rid of the whole multiplier and just say y equals 2 as our solution, or our equation. Let's look at this line. Determine the equation of the line. This one's a little bit more challenging. There is no y-intercept. Right, if I were to go down my line, my y-axis, there is no y-intercept. If I were to plot the points, or sorry, no y-intercept, if I were to take 2 points, I can see that I have a rise of -2, but a run of 0. So if I was to do rise over run, I would get -2 over 0. Right? So I can get a multiplier. Right? So let's look at the table, x and y. So when x is 0, y is 4. When x is 1, y is 4. When x is 2, oops, sorry, no, that's wrong. Not when x is 0. When x is 4, y is 0. When x is 4, y is 1. When x is 4, y is 2. When x is 4, y is 3, and so on. I'm going to find my change in y and change in x. I see this is going up by 0. Change in y is going up by 1. So I don't get anything different, right? When I do my multiplier, change in y is 1 divided by change in x, which is 0, similar to the -2 over 0. And if you were to enter this into your calculator, you would get an error, or what we call undefined. You could think of the slope being so high, right? If you're thinking of slope as the steepness, this is so high or so steep that we cannot define it in values like we're used to. So what does that mean for our equation? We don't have a multiplier. We don't have a y-intercept. What's our equation? Well, for this one, I'll tell you. Right? If I look at this equation, what do we notice? Or if we look at the table, we look at the graph, what do we notice? We notice that the y values can change, but what is always staying the same? What's always staying the same is the x value. X is always going to be equal to 4. It does not matter what the y value is, the x value is always going to equal 4. So in that case, we can say that the equation is going to be x equals 4. Because it doesn't matter what y value you have, the x value is always going to be 4. Similar to here, the y values, all the y values were always 2. So it doesn't matter what your x value is, y is 2. Same thing here. Doesn't matter what your y value is, x is always going to be 4. So it is kind of a little bit backwards, right? Because we think y as the vertical and x as the horizontal. So you kind of have to really think about, well, if x equals 4, what does that mean? Does that mean that the x values are changing as we see in a horizontal line? Or does it mean that the x values are staying the same and the y values are changing? So we want to be careful about that, and it's almost something that you have to kind of memorize or really reason through. So just as a summary for a horizontal and vertical line, right? So for a horizontal line, we're going to have the formula y equals, we'll say b, because there will be a y-intercept. For a vertical line, we'll say x equals a, right? X equals a value. Horizontal has a slope or multiplier of 0, and it does have a y-intercept. For a vertical line, the slope is what we call, slope is undefined. and it has no y-intercept. No y-intercept, or it's all y-intercepts, right? We could have a vertical line that is the y-axis, but for our general purposes, I would say that the vertical has no y-intercept. So that's just a quick summary, right? Y equals b, right? Where the y-intercept for the horizontal has a slope of 0, has a y-intercept. So we might say y values stay the same. And for vertical, x values stay the same. So just as a summary, or just as an example, we want to determine the equation for the following lines. Right, so for A, it is a horizontal line, so it's going to be in the form y equals b. And in this case, because the y value that it crosses at is 4, or sorry, not 4, 3, we can say that y equals 3 for A. For B, right, is a vertical line, so it's going to be in the form x equals A. X is going to equal the x-intercept, or the value that it goes through, and in this case it goes through -2. For C, another vertical line, so it's going to be x equals, and because it goes through 6, it's going to be x equals 6. And finally for D, horizontal line, so it'll be in the form y equals, and it will be y equals -7, because that is the y-intercept, or the y value it goes through, or that it stays at. Right, so just really quick, two pairs of unique lines, right? One parallel and perpendicular, focusing more on the slope or the multiplier of the two lines or relationships, and then horizontal and vertical. These are just unique situations, again, referring to the slope, as well as some other characteristics. So make sure you are familiar with the characteristics of these different types of lines.